Okay, so at the risk of making some mistakes here with my video software, I'm going to flip up the schematic. And on the last video I tried this on, everything went silent because I didn't attach a microphone or click a microphone on. So it's going to look a little stupid for a moment, but this is the way it's got to go as far as I know. Here we go. Okay, with any luck at all, there, you're seeing the schematic and hearing my voice at the same time. Yeah, I think I got it. I think I got it. So, one of the things I often say, and I don't think I've ever said it on a video, is usually when we're talking about the world and the condition of things in the world, and what people are doing, at a world level, I often say, people not ready. We're not ready to run the world. We're still too stupid as a species to take on the running of the world. And I think the evidence is all around us. Well, you know what? The same thing applies to Jim. Jim, not ready to run all this video stuff. But I'm going to do it because I got to get on with things. So as I stumble along in here, both stumble while I'm trying to fix radios and stumble with the video, I hope you'll tolerate it. In fact, what I've experienced here on YouTube has been really something. I thought I would get beat up quite soundly as I put these videos out. I'm not going to do everything the way everybody thinks it should be done, and I'm going to make mistakes and on and on and on. And I thought I'd really get the crap beat out of me by comments, but quite the opposite has happened. And I have to go answer my phone. Okay, so that wasn't the early morning, do you want your ducks clean phone call? That was a wrong number. I think with all this modern technology and all this stuff that somehow the wrong number would have been eliminated, but no, it still happens. So, okay, so now I'm totally lost. What am I doing? Oh yes, okay. Put the screen up here for you to look at. And I'm trusting now you're seeing exactly what I'm seeing, but I know you cannot see my cursor. And that's a little bit unfortunate. So, but let's talk our way through the schematic. I started studying it on my own here and realized I could do this on screen and really just drive you nuts. So let's do that. Okay, so I'm thinking the problem with the radio is there's no oscillation on the high band. So if we look at the oscillator, that's the second tube from the right, called the 6A8. It says under it, first detector oscillator. So if you look down below that tube on the schematic, you see 3 coils. And if you look close enough, you'll see a little switch, 2 switches in fact. If you study that for a moment, you'll see that it's actually the switch is selecting which one of those coil sets or coil pairs or transformers should be switched in. So I'm pretty sure those are the oscillator coils. In fact, there's really no doubt of that. So the problem could be something wrong with the oscillator coil. Unfortunately, it could be an open coil, preventing the oscillator from oscillating. Could be capacitors. Now, which coil is which there? Well, 3 bands, 3 coils. We can guess the coils are shown in order of their, in the same order that the band switch operates. It's a relatively safe assumption because they show the switch right on the circuit diagram. And okay, so that would make, I'm guessing, the radio is shown in this schematic as being in the AM broadcast band. I looked for a note. Often there's a note on these schematics that tell you that, but there's no note on here that I could find. So assuming the top coil is the AM, then the bottom coil on the diagram, the lowest coil, has to be coils or transformer. That has to be the one that we're concerned about. So I'm looking at it here. I see a couple capacitors. I see C11 and I see C9, I think that is. And it sure looks like if either of those have gone to ground, that would be the end of, if either of those are shorted, that would be the end of that band oscillating. Now there's something curious I just noticed, and that is the the two shortwave coils, that'd be the middle coil and the lower coil or transformer, the two of them are hooked in series on the left side of the transformer there. So I'm not sure what to make of that. You know, other than, you know, just off the top of my head, obviously you add the two coils together, you get, well, why would you add those coils together? What's going on there? Well, I think I need to study this a little closer, because when that band switch is switched to the opposite position of where it is now, that one side of it is being, I don't know how to analyze that exactly. But maybe we're going to overthink it here. I shouldn't think it's so hard. Maybe the oscillator is oscillating. There's really no problem there. But that's the first area we're going to poke around in, the coils, and we'll check these capacitors a little bit if we can, and look for something out of sorts. Now, on the radio, if you look over towards the right corner where you see a diagram of actually the left. Well, actually, let's look at both diagrams here of the chassis. The one on the right is looking underneath the chassis, and you can see where the oscillator coil is located, right in the top right-hand corner of the chassis, sort of. If you look long enough, you'll spot it there. The coil goes right over top of the 6A82. That makes some sense, doesn't it? They put the oscillator coil right next to the 2 to shorten all the wires. And wouldn't you know it, no one caught me on this one yet, but when I aligned this radio, I adjusted the number 1 IF transformer, and I overlooked the number 2. And that's because the number 2 is completely different from the number 1. It just didn't strike me. And I've seen it on the schematic a number of times. I kept looking for it in the radio and not finding it. So I'll show you what I mean by that. So we look here at the radio once again. Let me just bring in a little bit closer. We see these three big coils. This one's the oscillator coil up here. Now, if you look right over here, okay, you can see the first IF coil right here. And if you might remember, I tuned capacitors in the back here. They're right on this wafer. You know, when I look at the schematic here, okay, so I see the IF. Here's another one. But I've looked in this radio, and for the life of me, I don't see another one of these anywhere. And why is that? Tell them why that is, Jim. Because it's actually on top here in the standard can. There's a can. And somehow I just didn't see these things and realize them. So, and guess what? Nobody watching the videos saw it either. Unless you're holding back your comments from me. So we're going to have to align that IF. If I remember right, we got a little bit of lift from the first one. And actually, talking about the first IF, it still has the capacitor that I adjusted that had no effect on anything. And it certainly shows up in the schematic looking like an ordinary capacitor bridging the coil. I don't know, we should look at that a little closer too. So there's quite a few things now to look at and try and sort out. So first, is this radio oscillating? Let's try to figure that one out. So just doing a quick safety check here. And everything looks good, except I know what I'm missing. I'm missing the speaker. Let me get the speaker. Okay. I very cleverly left the clip leads connected to it so we can plug in the speaker right back into my output level meter. case we need that. Okay, quick safety check again. Everything's looking good. So I think we can start up this radio. And then before I do that, actually, I really should figure out where to hook up my oscilloscope here. So probably, see, I'm worried if I try to detect the output of the actual oscillator coils on that side, the impedance of all that is so high, my oscilloscope will disturb it. Well, let's give it a try. So that would be pin number would look like pin number 1, 2, 3, 4, 5. I think it's pin number 5 on the 6A8. Okay, the 6A8. Where are you, the 6A8? Right underneath the coil. What am I saying? Right under here. So we want to hook up the oscilloscope. I think I'm going to do that right now. To pin number 5, right? 1, 2, 3, 4, 5. Pin number 5. Oh my gosh, let me try to spot pin number 5 in here. Maybe you can help me spot pin number 5 if I give you a chance here. Okay, so there's the close-up, and you saw how the camera was angled. And in there's pin number 5, so I can see the key on the tube really clearly. Now that's easy. So 1, 2, 3, 4, 5. Now, it looks like there's a nice wire coming off that pin. Onto the, there we are, there's a good view of it now. So you can see that resistor there. It's like a, I'm going to guess 47K. I think I can get my scope. It's kind of good to do this without the set operating here, right onto that. Once again, the camera's right where I want to put my hand and my eyes and everything. I got it. So there it is. So that's on pin 5. That's just a ground wire I'm putting on. Not the best connection. Maybe we'll do another ground lead here too. From the scope ground, right there too. Okay, so I think we're ready to operate the set, and take a look at what we get as a result. On the oscilloscope. I got to come up with a real nice camera arrangement for the oscilloscope here. And I don't have one at the moment. I got to come up with something clever, like holding the camera. That's about as clever as we're going to get here, I think, at this point. So I will do that when the time comes. So we're ready to start this radio up now. Let's see, one more quick check. Anything too stupid here. There we go. Okay, and the lights came on the radio. We are on current restriction, so take a little while to warm up. Give it a bit of volume here. Here it comes. So first thing we're going to do is look for the oscillator signal on a band that's operating. Then we'll know that our ability to see the oscillator signal is there. Then we'll go looking for it on the other band. That's my approach here. So now we already have the radio hooked up, the scope hooked up. I'm just adjusting it over here out of your view. And there's quite a strong signal at the point where I connected it. This might be a little hard on my camera here, but okay, so here's the scope. Let me get rid of the other trace. Okay, so that's the trace we want to look at right there. Let's see, triggering on. Doesn't want to trigger. Doesn't really matter. Let's see if we can trigger it here. There it is. Okay, so there is the oscillator frequency for this band, and I'll tune the radio, and you should see this frequency change. Now I gotta kind of, I'm holding the camera in the air here, so bear with me while I lose sight of everything I'm doing. While I reach over. Okay, here we go. Now watch that. Okay, see it change? And you know what? I never made sure I was on the AM band. I think I'm still up on the high band. And that's easy to find out. I just changed bands here. No, that's got to be AM. Let's tune a little more. I have no antenna connected to it, so okay, so that's the AM band. Now we'll go up to the next band. Now the frequency has gone way up. It may well be beyond my scope here. Oh no, there it is. I'm still able to freeze it. Once the signal's gotten weaker, I had to turn up my scope to see it. And now we're going to go up to the next band. Well, it looks like something's there, doesn't it? Freeze it. There it is. Now we'll tune the radio. And it certainly is changing. Notice the size of it is going up and down too. It's much larger down here. Not sure if that is any bearing on anything or not, as long as there's enough there. Sorry about the shaky signal, but, well, there you go. It's oscillating, no doubt about it. Okay, so much for that theory. It's not oscillating theory has gone down the drain. And, that's good in one way. We know what it's not. The problem now is I got to come up with a new theory. So let me de-scope this thing here. Curious effects when you let go, take off grounds and things like that. I don't know what to make of that. Why the radio went quiet just because I took off my oscilloscope and ground. Maybe somebody can answer that curious thing. So, what do we got here? What do we got here? We got the need to stop and think for a bit. So that's what I'm going to do. Just stop the video and think here for a little bit. Okay, just a little bit of thought, and I think I better verify again it doesn't work. Because I've done this before where I've reached the conclusion something's not working, troubleshoot away for quite a while, only to discover in the end it actually was working the whole time. That's really not what I want to have happen here. So look at that. I mean, it is responsive. That's I'm just hooking up the antenna here. I'm dialed into 10 megahertz on the radio, so we're going to dial that up on the signal generator. As you can see right up there. And I'm tuning the radio now to. There's absolutely nothing. Okay, what's our next move? Our next move would be, I guess we could guess that we could continue feeding the signal in the antenna and attempt to see it on the scope. Turn my scope back on. See it on the scope coming out of this tube. Out of the first RF amplifier. And we would find that on pin 3 of the first 6K7. So that would be this tube here. Pin 3. 1, 2, 3. Let's see what happens if we touch the scope to that pin. Everyone's reaching for their headphones, I hope. Well, what did I say? Let's double check here. I thought it was pin 3. 1, 2, 3 is the plate. 3 is the plate. Why don't we just stick a capacitor in there? Shouldn't need to do this, I don't think, but because I think the well, maybe not, you know. I'll take that back. Oh, that's great. My little ground wire just broke off. There we go. Isn't this a wild thing? Now, pin number 1, 2, 3. Just looking. Okay, there's definitely a signal there, so it's something worth looking at. Let me hook this up a little more permanently here. One, two, three, that's definitely the guy right there. Okay. We are connected. And I'll show you what we're seeing here. Once again with my handheld camera, so I apologize for the craziness. Now, let's get this a little bigger. So there's what it's picking up. This is the output of the first RF amplifier. And I would imagine that's the amplified 10 megahertz signal I'm feeding into the radio. But let's cut that signal back and see if this signal doesn't cut back also. So here we go. And look at that, it didn't change a bit. Okay, so I missed the mark. This is not what I think it is. This is something else. And what else could it be? That's an interesting question. That sound you just heard to me sounds like a thermostat switching in somewhere. I would have thought my furnace might pop on, but it didn't. Okay, gotta stop and think some more. Okay, now one thing is I still have this radio running on restricted power, so it's not at full voltage. It's running around 95 supplied volts, so that may not be helping the situation. I'm going to leave it as it is right now. I think what we'll do is we'll just move even further ahead. We'll go from the plate of the first RF tube to the grid and see if we don't see the signal on the grid. I mean, that's kind of, it better be there. The grid is 1, 2. Pin number 2. So the grid is right. You know what? You know what? I got a capacitor in there. Let's take a closer look at this. See if I can find out where the camera is. Here it is. Okay, ready for another embarrassment here. Oh, the things that come out. Maybe it's not an embarrassment. Okay, so there's a close-up of the tube socket. You can see my big black clip lead there on pin number 3. I'm just about to move it to pin number 2. And that capacitor lead, I mean, it doesn't look soldered in. It's okay on the other end. It probably is soldered in, it just doesn't look it. When I look with my own eyes, it's even more questionable. So I'm going to wiggle that a little bit and see what happens. And then I'll move the clip lead. Now I got to remember the radio's operating here, and I'm wiggling a wire on the grid of the RF tube. That's let's just turn the volume down a little bit. Spare ourselves the. No, that wire is soldered in there. You just can't see where the solder is. So, okay, so we're going to move the clip lead to the grid. This may silence the radio. I don't know what's going to happen here. How about nothing? You kind of expect something to happen when you fiddle around with these in these areas. Okay, so now, you know what? That goes straight to ground there. Oh, okay, back up, everybody, back up. Okay, counted the pins wrong. Or did I? Let me get my head right in front of the camera here first. In fact, you know what? I'll use the other camera. We'll take a closer look. I think I actually got the pin count wrong on that too. I did get the pin count wrong. What I thought was 3 is actually 2. So we were on the grid. So 3, okay, great. We're on the grid. We're on the grid, but okay, let's hey, if I got I was gonna say if I got the pin count wrong, maybe I put that capacitor in the wrong spot there. But that's not so likely. Or is it? We'll have to check that, I think. Oh my gosh. All this stuff that happens here. So that would be the capacitor is connected to, I'm going to stick my head right in front of the camera here. Get a good look at it. Pin number 1. So pin number 1 okay, I'm just going to ponder this in silence for a little bit again. Okay, so part of the fun of doing this on camera is that every little mistake I make gets caught, whereas in real life, when you make little mistakes, you kind of breeze by them and carry on. You don't think much about them, but Unfortunately, they all get kind of tallied up on video here. So mistake is simple. I'm looking at this diagram here, forgetting that there's a grid cap on this tube. So I look really closely at the diagram. You can actually see the grid number 1 lead doesn't connect to the pin number 2. I mean, it's coming out the grid cap. It's not readily apparent on this diagram, so I'll blame it on that. Blame it on this. So that's easy now. We can switch up to the grid by connecting to the cap. See the signal coming from the antenna into it, and then we'll look at the output, which we realize now is pin 3. Now I was on pin 2, and what is pin 2? Pin 2 is pile of nothing. Pin 2 is the heater, for crying out loud. Pin 2 is the heater and it's grounded. Boy, none of that adds up, does it? Well, just ignore all that. I'm going to. I'm just going to carry on here and repeat a few things. So let's look at scope on the grid cap. It's not making any noise when I do this either. Boy, and if I don't see the output here from the signal generator, that's really going to tell us something, I think. Won't it? Okay, so I'm seeing a signal there on my scope, but not what I expected. So what have I done here? Scope is connected to the grid cap. The grid cap is connected to the maybe I should, you know what, ground my signal generator. Oops. Don't get excited now, everybody. Remain calm. Remain calm. I think I need to ground my signal generator. That might change the picture here a little bit. On the other hand, might do absolutely nothing. Now here's another thing that would be really good to do, and that's plug the lead into my signal generator. Oh my God, I've had this thing on an antenna the whole time, not on the signal generator. Oh. Okay, I have to put that one in the category of you're being stupid here. So now, just hesitating here. Volume down. Okay, now we're on the signal generator. Oh my God, all this time I have not had the signal generator pumping into the radio. So let's start over. Okay, tune the radio to 10. Radio is tuned to 10 megahertz. I see the red dot on the dial setting, so there's no question. We're on the right selector. We're at 10. Turn it up. Scope signal, or generator signal, definitely going into the antenna now. Got something on the scope too. Interesting. Can we receive the 10 that's piling into the antenna? Let's tune and see. And the answer is no. Okay, tuned on 10. I'm going to move the signal generator around just to... Sounds like no reception whatsoever. Okay, I'll show you what's going on my scope now. We are... If we didn't see the signal at this point, I'd almost want to start crying. So there's the signal coming in. How do I know that's coming from the signal generator? Because if I do this, nothing happened. What? Can anybody explain that one to me? You pull a signal right out. Well, there's still something here right around 10. Why is that? Let's tune the radio a bit. Oh my gosh, what am I getting here? I'm getting the local oscillator frequency or something. It's not at all what I think it is. Okay, okay. Everybody back the bus up again. Not everybody's on board here. Hey, time for another stop and think thing. You know, most of these stop and think things, I'm only stopping the video for like 2 minutes. But I think I'll stop it. Okay, so let's take a look at the schematic together. Bear with me while I try to make this work here. Okay, so hopefully you can hear me talking still. I think I can verify that. Yes, you should be able to hear me talking and see the schematic. Now, let me turn down the radio too so you don't have to listen to that. Well, I knew there was always a problem with a bit of the local oscillator signal making it back to the antenna to be broadcast to your neighbor's radio. And this was something that radio engineers and I think even governments tried to regulate and prevent. So the reason I'm bringing that up is because I'm now got my scope right on the antenna. Here, I'll show you what you see. Yeah, there we go. Still not 100% at using my software effectively yet, so there you are. Now that looks like the output of my signal generator, but I can tell you the signal generator output is turned right down. That's why my frequency counter is jumping here. It's got no signal to count. There's no signal, or very little signal coming out of the signal generator. If I tune the radio, there we go, you can see that change dramatically from tuning the radio. And what exactly am I connected to? Okay, we'll start here. Here's my scope, lead, and capacitor, and that black wire right on the antenna connection. So I'm scoping the antenna connection, and I'm seeing the signal from the local oscillator. And when I compare it, I didn't do this for you. When I compare it to the signal from my signal generator, the oscillator signal is way greater, and it's the same on every band. And we know 2 of the other bands are working, so I don't think this is really representing a problem. So let me struggle my way back to the whoop, 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 whoop. Okay, there we go. I better just double check and make sure you can still hear me. Yeah, okay. You know, some of the challenges I'm facing on the video side here is I'm using one screen on my computer. Just what I'd love is to have 2 screens in here and double the noise, but I'm using one screen, and sometimes I have to lay things on top of other things. Can't see them anymore on my screen. That's what's happening right now while we're looking at the schematic. Now, so the 6A8 second tube in on the radio is the one that does the oscillating, and from there the signal is making it all the way back through the first RF tube and out to the antenna. Now, that's just a little bit hard to believe, but I see it and you see it. The part that's really hard to believe is the signal on the antenna from the local oscillator is way higher than any radio signal coming in. And I'm not so sure that's normal. I mean, maybe it is normal for this radio to do this. That would mean as you tune this radio around, you'd be firing signals into local, your neighbor's radios and that. Probably wouldn't matter today. Who cares? But back in the day when there wasn't that much radio stuff in the ether, so to speak, a little bit of extra stuff must have been quite noticeable. Okay, what to do, what to do. I think maybe I'll stop at this point and post some of these videos and look for some intelligent comments to come back. Or else what I'll be doing is I'll be continuing the work and then reading comments on the stupid things I'm doing. So to avoid that, I'll let some smart people give me some ideas on what to do next. So here's just to run through the whole thing again very quickly. Radio's working virtually 100%, noise gone, everything sounds good. Two bands appear to be working fine. Third band, the high shortwave band, appears to receive nothing but a little bit of noise you hear now. The oscillator certainly appears to be oscillating, and in trying to trace the let's say a antenna received type signal, like a regular radio signal, trying to trace that through the radio has not gone well at all, because the first thing I've noticed is the local oscillator signal is present at the antenna and is swamping any signal that might come in, so I can see it on my scope. So I'm going to leave it at that and look forward to comments on it.